Hello students, in last lecture we have discussed impurity, its types and sources. So in today's lecture we will discuss about limit test. First of all, we should know why there is a need to study limit test and what are its importance. As we have already discussed in last lecture about impurities, as we already know that impurities are hazardous, it may contaminate our product. So to avoid that, there is a need to study limit test. In short, limit test means what? They are a quantitative or semi-quantitative test designed to identify or control small quantities of impurity. This test should be specific and sensitive. Here you can see here apparatus required for limit test is Nestle cylinder. Then limit test shows three types. How we can determine the impurities present in the sample. First one, that is the comparison method. Second one, quantitative determination. And third one, test in which there is no visible reaction. General principle of limit test. What it says, if the sample is lighter than standard solution, then it is within the pharmacopoeial limit, that it will be accepted as per standard value. And if the sample is darker or heavier than standard solution, then it is rejected. It means limit test is carried out to find out the impurities present in the sample. For that we have to compare two solutions. First of all, first solution will be of standard and second will be of test. Test means the compound from which we have to determine the impurities. Then we will see the diagram over here about Nestle cylinder. Nestle cylinder, it is the apparatus which is required to carry out the limit test. Clear glasses with normal capacity having 50 ml. Overall height about 15 cm. External height required is 50 ml mark, 11 to 12.4 cm, and the thickness of wall is also given, that is in between 1 to 1.5 mm, and thickness of the base required is 1 to 3 mm. External height to the 50 mark of the cylinder used to test, it must not differ by more than 1 mm. So this is the diagrammatic representation of Nestle cylinder. In Nestle cylinder we have to carry out limit test. So general precautions are also given over here. Before we start limit test, the liquid used must be clean and filtered if necessary. The Nestle cylinder must be made up of colorless glass and of the same inner diameter. Detecting opalescence or color development must be performed in daylight. When comparing turbidity, it should be done against black background, and when comparing color, it should be done against white background. These are the general precautions that we have to take before starting limit test, because as we know that by performing limit test we can determine the impurities, we can identify the impurities present in the sample, and we have to do the comparison method for that. And if we have to compare the two solutions, then that two solutions must be of same. So Nestle cylinder required for both, it should be of same size, same diameter. Here in this diagram you can see solution is there in Nestle cylinder. By checking its opalescence. What is the meaning of opalescence? Opalescence means turbidity. Means transparent solution is formed in both of the Nestle cylinders. By performing or by observing the turbidity of that solution, standard and test, we can compare both of the solutions and we can conclude that limit test is complies or not. So here This is the general information regarding limit test. In our syllabus, total 5 to 6 limit tests are given. We will see one by one. As we know that impurities and its types we have seen: chloride, sulfate, iron, arsenic, heavy metals. All of these are included in impurities. If the concentration of all of these constituents is greater, then it may cause contamination to our final product, and to avoid that contamination there is a need of limit test. So first we will see limit test for chloride. Chemical reaction is given over here. You can see Cl minus, that is a chloride, plus silver nitrate, it will give silver chloride. So you can see here two Nestle cylinders. You can see here one for standard and one for test. In both of these Nestle cylinder, up to the mark, that is up to 50 ml, all solutions are filled. Which solutions are required to perform the limit test for chloride? You can see here 1 ml silver nitrate is here, then distilled water along with 1 ml nitric acid, then 10 ml standard chloride solution is required in standard, and in test, whatever the sample you have to taste it, from that you have to identify the chloride impurity. That sample you can take. We have taken sodium bicarbonate sample, and in the same way we have added all the constituents which we have added in standard, so we can compare the turbidity of the solutions. If we see the principle of this, what is the principle? Principle is nothing but the mechanism how reactants are converted to product, how reaction is occurred over here, how chloride react with the silver nitrate with the help of other reagents. So we can determine the impurity of chloride present in the sample. See, this test, which is mainly used to control chloride impurity in inorganic substance, it depends upon the simple reaction between silver nitrate and soluble chloride to give insoluble silver chloride in the presence of dilute nitric acid. The insoluble silver chloride makes the solution opalescent, and the extent of opalescence depending upon the amount of chloride present in the sample, that we can compare with the taste. As per the standard value, we can conclude that whether that sample complies the limit test or not. Actually, we are dealing with the chloride impurity, right? We have taken sodium bicarbonate as a test sample. In that, we have to identify how much amount of chloride is present in that sample, whether it is in permissible limit or not, that we have to identify. So if we see in both Nestle cylinders, equal amount of reagents are added in both of this. Just difference is that in standard we have taken a standard value of chloride, and in test we have taken sodium bicarbonate solution. Okay, so what are the roles of silver nitrate and dilute nitric acid over here, that we will see. So dilute nitric acid is added in limit test of chloride, especially why it is used, why it is required, because we have to determine only chloride impurity, but we doesn't know in the given sample, whatever the sample we have taken, in that sample along with chloride there may be the chances of presence of other impurities also, right? That means chloride, along with chloride there may be the presence of sulfur, iron, arsenic. So all of this may contaminate our final product. So to avoid this, all of these impurities, dilute nitric acid is required. How it works? Dilute HNO3 will avoid the precipitation of these other impurities like sulfate, arsenic, iron, and it will allow only to react chloride with silver nitrate reagent. So in this way, just chloride will react with the silver nitrate, not other ions, and we can determine the chloride ion impurity by performing this limit test. Got it? That is the role of dilute HNO3. Then silver nitrate, this is a reactive reagent, As silver nitrate has an affinity, it has a capacity to form a PPT with Cl minus with chloride ions. So it will form silver chloride PPT. And by observing the turbidity, by observing the opalescence of both of the solutions, standard and test, we can find out the chloride ion impurity present in the sample. Okay. So last conclusion is that if the opalescence produced in test is less intense than that of the standard, the sample passes the limit test for chloride. As we already know that impurities are hazardous, that means if impurities are less, impurities are present, no doubt, but it should be in less amount. Okay, it should be in negligible amount. If impurities are present in test sample is less than that of the standard, then of course definitely the sample complies the limit test. But if as compared to standard limit test of chloride, as compared to standard, if test shows greater amount of opalescence or greater amount of impurity, then it means that test does not comply, sample is not pure, so it is not used for further process. It is not in permissible limit, that is given by pharmacopoeia. It should be, as per the standard value, it should be 25 parts per million. It should not be greater than 25 parts per million. Okay, so this is limit test for chloride. Then I hope you will understand the importance of limit test in industry, how it will determine the smaller amount of impurities present in the sample by just comparison method. Then second, we will see limit test for sulfate. Chemical reaction is given over here, but before that we should know the procedure which is required for the limit test of sulfate. Whatever the chemicals which are required in limit test of sulfate that are given, barium chloride. First of all, sulfate will be there as a standard sulfate solution. Barium chloride will be there. Then acetic acid is also required in the limit test of sulfate. As the name suggests, it is a limit test of sulfate. That means sulfate impurity SO4 minus that we have to identify in the unknown sample. And sample for testing we have taken, that is again sodium bicarbonate. Same procedure is here. 2 Nestle cylinders are required having 50 mm in diameter. So in both of these Nestle cylinder we can add equal amount of solutions which are required to react with each other. So if we see in limit test of sulfate, in standard there is a standard sulfate solution is taken. Barium chloride in small amount is added. Along with that there is the addition of small amount of acetic acid. In same case is here in case of test. Sodium bicarbonate as a testing sample is added. In that barium chloride along with acetic acid is added. So reaction says that sulfate will react with barium chloride and it will form barium sulfate PPT. That we will observe in both of the Nestle cylinder. That PPT should be of barium sulfate only. So what is the principle in this? It is based upon reaction between barium chloride and soluble sulfate in presence of dilute hydrochloric acid. In presence of dilute hydrochloric acid, or also we can take acetic acid. Both of the solutions we can use. The comparison of turbidity is done with the standard turbidity obtained from a known amount of sulfate and same volume of dilute HCl in both of the solutions. In IP, Indian Pharmacopoeia, barium chloride solution is replaced with barium chloride reagent to enhance the reactivity of the test. If we see the principle of this reaction, again the role of chemicals, mechanism, sulfate that we have to determine. Barium chloride, it is a reactive reagent which is again reacted with the sulfate sample and it will form barium sulfate PPD. So acetic acid or HCl we have used in this case. Why it is required? As In earlier case we have seen in limit test of chloride there is a role of dilute HNO3. Same case is here also. In limit test of sulfate there is a role of dilute acetic acid or dilute HCl. That means to avoid the presence of other impurities and to only give a chance to sulfate ions to react with barium chloride, there is the addition of small amount of acetic acid is required in this reaction. Then ethanolic sulfate standard solution is here. What is the role of ethanol? So this sulfate standard solution is prepared in media of ethanol. So ethanol is used, it is required to prevent the supersaturation in this limit test. Then if we see the PPT of this barium sulfate in both of the Nestle cylinder in standard and test, of course there will be the reaction in standard as we have already added sulfate in that, so it will form barium sulfate PPT. But if we check the impurity present in the test sample, so test will show less intensity or more intensity as compared to the standard, that we have to check. If in sodium bicarbonate sample sulfate present it is in more amount, then definitely it will show higher amount of impurity, higher amount of opalescence will be there. It will react with barium chloride and it will form more amount of barium sulfate PPT in taste. And if sulfate in sodium bicarbonate sample it is in less amount, it is in negligible concentration, then it will form less opalescence or less turbidity will be there as compared to the standard. That just we have to check. Means students, you can see here we cannot calculate the amount present in the sample. It is a qualitative technique. By comparing both of the solutions, standard with the test, just we can conclude that whether that test complies or does not comply, whether that sample is pure or it is impure. From this we can say that as last observation is same, if intensity present in the test sample of impurity is less as compared to standard, it means it complies the test passes, that sample it is impurity, it is in permissible limit and it can be used further process. But if that impurity present in test sample is greater than as compared to the standard, then definitely that compound is not good for our health, it is not pure. That means we cannot use that compound for further process. Okay, so this is regarding limit test of sulfate. You can see here the reaction I have given. Just on arrow there is a presence of acetic acid, that is not given here, but you have to write acetic acid on arrow, or also you can write dilute HCl. Then limit test for iron, that is the third limit test. Procedure given 20% citric acid, it is 2 ml, 2 drops of thioglycolic acid, 10 ml sample. Then to make solution alkaline there is the addition of ammonia reagent also. Citric acid is also added in both of this, in standard as well as taste. Chemical reaction is written SHCH2COOH. This is the chemical formula for thioglycolic acid. Actually thioglycolic acid, it is a main reagent which is used in limit test of iron, so don't forget. So again same 2 Nestle cylinders are required. Students, if we see in 2 limit test in chloride and sulfate there is also use of Nestle cylinder. In limit test of iron, in limit test of heavy metal, in limit test of lead there is also use of Nestle cylinder. What special limit test is here, that is the limit test of arsenic, that we will see in next lecture. It uses arsenic apparatus, special apparatus, that is a gadget apparatus is required for the limit test of arsenic. So that is the speciality of arsenic limit test, that why it is required and why not Nestle cylinder, that part we will see in the next lecture. So Coming to our point, that is the limit test for iron. First of all, we will see the role of each and every chemical that are used in iron one by one. Thioglycolic acid, see the principle. The limit test of iron is based on the formation of pale pink to deep reddish purple color by reaction of iron with thioglycolic acid in presence of citric acid in a solution. It is made alkaline with ammonia solution. The color is due to formation of coordination compound ferrous thioglycolate. You can see here the complex is formed between the metal and ligand. Iron is a metal and ligand is thioglycolic acid. The original state of oxidation of iron is immaterial since thioglycolic acid also reduces ferric iron to ferrous state. Okay, so we will see one by one what is the principle of this. If we see the reaction in first, you can see here Fe3 plus means ferric. Oxidation state in first reaction of iron, it is in ferric form. So it is immaterial, that means ferric is not be able to react properly with thioglycolic acid. It will not form a complex with this thioglycolic acid. So what we have to do in first case, in first step, thioglycolic acid react with ferric ion and it will convert ferric to ferrous, that is Fe2 plus. You can see here in the product side there is a formation of ferrous. Ferric Fe3 plus and ferrous means Fe2 plus. Remember this. Whenever we have to complete any reaction, we have to form any product. In reaction, there is a role of temperature, there is a role of oxidation state, there is a role of pH. All of these things are necessary to carry out the reactions. And if we does not maintain this reaction conditions, reaction will not occur in that way. Okay. So first there is a need to convert this ferric to ferrous, and for that purpose we have used thioglycolic acid. So first step is clear. In second step again ferrous is there, so ferrous will completely react with the thioglycolic acid. As already I have said, thioglycolic acid is the main reagent used in limit test of iron. So thioglycolic acid will react with the ferrous and it will form ferrous thioglycolate complex. That will be of purple, reddish purple in color. You can see the reaction even over here. Two arrows are there. Thio means sulfur. Okay, so acidic functional group is there, COH will be there, and it is a thioglycolic acid. Main element is sulfur over here, because as we know that sulfur shows a lone pair of electron. It will easily donate its electron pair to the metal ion. Metal is formed in central position. You can see here Fe, and sulfur will donate its electron to this ion. So that's why the arrow is like this. That is a coordinate bond. Coordinate means whenever there is a in process in which electrons are shared by one species to other species, that is sulfur will share its electron, it will donate to metal ion. That's why the head on metal ion is there, and tail from where electrons are transferred, that are from sulfur only. So oxygen is not used in this case. That's why two only coordinate bonds are here. Remember this. And this is known as coordination complex between metal and ligand. Ligand means which donates electron to the metal ion. Okay. So this is a ferrous thioglycolate complex is formed. So what we see in Nessler cylinder, you will just see the color change, right? Reddish purple color. But actually from where it comes from reaction between ferrous and thioglycolic acid. And when both of these reactants will react with each other, it will form a reddish purple color to that solution. We have to just compare both of these solutions. In prior cases, we have seen colorless compounds, chloride and sulfate. Only white color turbidity we have seen. But in this limit test, there is a special case. Here, instead of white color, there is a reddish purple color complex in between metal and ligand. And just by observing the intensity of the colors of both of the solutions, standard and test, we just have to give our result. Then we have used citric acid in the case of limit test of iron. What is the role? So already we have used ammonia. Ammonia, as already I have told you, we have to maintain certain conditions for some reactions. So if we have to maintain the pH in basic range in alkaline condition, ammonia is required because ammonia acts as a base. It is a basic in nature. So it will maintain the pH in between range of 8 to 14. And if we maintain that pH condition, then and only then ion will react with the thioglycolic acid. Otherwise, it will not form a complex. But in some cases, this ammonia also can form PPT with ion. We have to target only ion with thioglycolic acid, right? But ammonia also can form PPT with ion. So what we can do? So to avoid that interference of ion with ammonia, there is a use of citric acid over here. Are you getting my point? Citric acid is used to avoid the precipitation of ion with ammonia. That is the role of citric acid. For that purpose, citric acid is required. Okay, so already you know that the role of citric acid, the role of thioglycolic acid, the role of ammonia solution required in this. So what will be the conclusion of this limit test? See, same color produced is compared with the standard color containing a definite quantity of ion by weaving transversely against white background, because in prior cases we have used black background because it is a colorless, but in limit test of ion it is a color solution. That's why we have to use white background against which we have to compare both of the solutions. Simple. If intensity of impurity is greater in taste as compared to standard, that means taste sample is not good, taste does not comply. And if it is less as compared to the standard solution, then taste complies as per the given value of pharmacopoeia, as per the pharmacopoeia standards. Here is also one note is added. Citric acid is added in the official process to prevent the precipitation of ion by ammonia. That I have already told you. Ion gets precipitated in the form of iron hydroxide, ferrous hydroxide and ferric hydroxide depending upon the oxidation state of ion in presence of ammonia. So citric acid makes soluble complex with iron, and ammonia will not be able to precipitate ion and it will just provide alkaline medium. Okay, got it? So this is regarding the limit test of ion. In exam you have to write its principle, whatever the requirements are there, which chemicals are used, which apparatus is required, what is the principle, what are the roles of each and every chemical. If you understand all of these things, definitely you will learn limit test. Okay, so today we will stop here. Next point we will continue in next lecture. Thank you.